Hello and welcome. My name is Michael Carney and I am an applications engineer at EWI. I will be presenting on the topic of robotic GMA DED AM lattice structure demonstration. The lattice structure build is a stainless steel lattice that was produced using 0.045 inch diameter ER308L wire on an alloy 304L build plate that was 1 inch by 12 inch by 12 inches. The dimensions are shown in the upper right. The lattice is 2 beads wide in thickness and is 10 inches by 10 inches by 1 inch tall. The system used for this build was a dual-arm system that was integrated by Genesis Systems. The left side is a Fanuc ArcMate 120 ID paired with a Fronius TPS 5000 CMT welding system that is capable of GMAP, GMA, and CMT. The right side is a Fanuc M20 IB/25 that will have an SBI Plasma Arc GTA system capable of dual and single wire feed. This system also includes automated interpass temperature control. Lastly, by using a 2-axis positioner, it is also capable of building single or double-sided build platform structures. This pictogram is courtesy of Autodesk and shows the 10 additive build categories. These increase in complexity from 1 being a linear extrusion to 10 being artisan. The coupler being produced here is a build category 2. This pictogram is again courtesy of Autodesk and it shows the digital data workflow in 7 steps. Step 1 introduces the CAD component. Step 2 is where you preform or change the component for AM. Step 3 is where you set up the component in PowerMill. In this case, it is set up in a chuck. Step 4 is where you introduce the trajectory. Step 5 is where you decorate or add specific process conditions to the trajectory. Step 6 is where you sequence the build. Here you can add items such as wire clipping or active cooling. And step 7 is where you simulate your build and output the NC program or robotic code. Here the lattice is presented in the digital data workflow. No modifications were made to the CAD model. In step 6, a subroutine is called to check the interpass temperature and weight is needed. Here the build strategy is presented. It is a 3-axis build on a flat build plate. 2 beads per layer with staggered integral starts and stops. The design and path plan are shown in the top, and the simulation model and cell are shown in the bottom. A metallographic section was also produced to confirm sound fusion. Here the final build is shown in the lower left. The build had a very consistent build profile and visually appeared to have complete fusion. A time-lapse video is shown to the right. After completing the build, the lattice was visually inspected to the intent of MIL Standard 2035 and no defects were found. A 3D scan was then completed and compared to the CAD model. Those results are shown to the right. Thank you.